Okay, another type I want to discuss with you is on pesticide. So pesticide is a substance that can kill or otherwise control an unwanted organism, or what we call it as pest. So there are many types of pesticide, and they are named based on their mode of action and the specific organism that they are trying to combat. For example, we have insecticide, herbicide, fungicide, and rodenticide. Okay, so insecticide are basically the chemical used to kill insect. Okay. Herbicides are chemical used to kill plant, and fungicide are chemical used to kill fungus, while rodenticide is chemical that are used to kill rodent. For example, rat, mice, etc. Okay. What all these pesticides have in common is that they have the property of blocking the vital metabolic process of the organism, whether they are insecticide or plants or fungi, and etc. But they have the tendency to block the vital metabolic process, where they can cause toxic to this process. Okay, that's why it can kill or slows down the movement of the organism. So basically, pesticide is widely used in agriculture sector. So now, most of the pesticide used are of synthetic chemical. Of course, there are other options where you can use organic pesticide for organic farming. Okay, where you use a natural pesticide, but it is a good option for to use natural pesticide because they are less toxic to human. They have less side effect. They use less inorganic and organic content. But most agriculture sector, they prefer to use synthetic chemicals as their pesticide, because synthetic pesticide can produce and harvest large amount of food with respect to small area of land. Other than that, with use of pesticide, you can also use less human labor than when you're using, for example, organic farming, because organic farming, they need more tedious work or more tedious care to produce, for example, a large amount of food whatsoever. But those that have, the country needs to produce more food, then of course they will prefer to use synthetic pesticide. Okay, some of the benefits of using pesticide is that it's for crop production, it's for food preservation, material preservation. We use less, for example, less instrument or less machine, and then it's for disease control. So previously, pesticide have been used widely to prevent malaria. Malaria has killed almost 1 million children per year, and it has also been used for other vector-borne disease such as dengue. And then, however, there comes to the side effect where it's related to toxicity to human. These pesticides, they are designed to be toxic. They are designed to be biocide. They are designed to kill, reduce, or repel insects, rodent, weeds, fungi, and so on. So that is why they also have the potential to cause toxics to human, because their mode of action is by targeting the system or the enzymes in the pest. So if this system or these enzymes are similar to human, therefore they can also pose serious hazard to human. And because of that, their impact on the environment and ecosystem. For example, if we put this herbicide for specific weeds, but if the crop that we plant have the same system or enzyme system that with the weeds, then of course both the crop and the weeds can be killed. And there are also been cases where there are growing concern on the effect of pesticides on children, because they are more vulnerable than adults, especially when you have a high dose, or when those children that are exposed have higher exposure to pesticide, then they are more vulnerable, either at high or low concentration. Okay, next I would like to discuss about the origin, transport, and fate. Okay, so in order for you to understand how this pesticide can affect our environment or human other organism, is that you need to know how these chemicals that are transported, and in the end what happened to the transported chemicals. Okay, they have different pattern and a persistent in the environment, whether it is air, soil, or water. Okay, and we need to know how they're transported so that we can predict the acute and chronic exposure, because it depends on the media of the exposure, which is air, soil, and water. So basically, this diagram shows you how this chemical, for example, how the application of the agriculture chemical, when you spray, what happened to the chemical. Okay, so when a pesticide is applied, okay, directly onto the target pest, for example, plant or animal, then the whole system will be affected, which include the crops, the soil organism, the applicators, that mean that, for example, the farmer, the bystanders, that mean that any people that are living around the area, or animals, and then also the wildlife. Okay, so here is where the chemical are applied. So, for example, you can use spray, granulate, or seed treatments. Okay, and then what happened? This is the first exposure, the people that are near to the land. Okay, and then from there, it can be emitted, it can undergo emission, or it can undergo drift. Okay, so once it's applied on the land, it can be emitted to the air and also to the target pest which we want to remove. It can be an insect or weeds or whatsoever, and then it can also be drifted to the surface water. So let's say if you have piece of land and then you have river nearby, this is the land, let's say this is paddy field, you apply the pesticide on the paddy field, so you have a river flowing next to the paddy field. So by emission through the air, then the pesticide can enter the surface water. Okay, so and then from there, this we hoping, actually, when we apply the pesticide, we hoping that chemicals can go to the target pest. Okay, that is the main aim. But then the chemical can also by drainage. Okay, let's say in the paddy field you have a drainage system that goes to the surface water, so you can also enter the surface water. And then some of the chemical applied to the pest also we tend to volatilize, okay, or evaporate into the air. And then from there, you can also have those that are evaporated into the air. It can affect the human, wildlife, and also plant through the deposition. During the process from the air to the soil, it can affect the human, wildlife, and also plant, and then it then deposited into the soil. Okay, from the soil, it can affect the terrestrial organism, those that are animals that are live in the soil, for example, worms or whatsoever. Okay, and then from the target pest, it can also leach into the groundwater. So from the surface soil, for example, it can leach out into the groundwater. And then from the surface water, it can undergo the process of sedimentation, where from the top surface of the water, it can be deposited into sediment through sedimentation process. And during the process, it will affect the aquatic organism. And then lastly, when it's deposited into the sediment, it will affect the sediment organism. So this is how the application of the pesticide can affect all the living organism in the environment, which are in the air, soil, and water. But the persistency of these chemicals, they depends on the physical and chemical properties, which are, for example, partition coefficient, degradation rates, deposition rates, and so on. And also some of them, the effect also depend on the climate. For example, it's raining or snowing or hot season, it all affect the transportation and fate of the chemicals. Next, I would like to discuss about the insecticide. We have a few types of insecticide, for example, organochlorines, organophosphate, and also carbamates. So basically, you use insecticide is to control disease or insect-borne disease. For example, malaria, yellow fever, or dengue, and so on. So basically, the other reason why we use insecticide is to prevent insect from attacking our food crops. So one famous one is organochlorine. It's basically organic compound containing chlorine. It is widely used because it is stable towards environmental degradation or deposition. It's very persistent in the environment. It has very low solubility in water. And because of that, they have high solubility in fatty material. For example, fatty tissue, because they are hydrocarbon light in living matter. So they tend to bind with those that have high organic content in our body, and that is the fatty tissue. And they are relatively high toxic to insect. These characteristics, they are stable, persistent, very low solubility in water, and high solubility in fatty material, is the properties of their bioaccumulation. What is bioaccumulation? Is that they tend to concentrated on hydrocarbon-like in living matter, which is the fatty tissue. So in this case, studies have shown that they tend to accumulate in fish and other organisms, and they're concentrated in the fatty tissue. And from there, the concentration can increase through the food chain, which we call biomagnification. So later, I'll show you what is I mean by biomagnification. Okay, for example, is HCB, which is hexachlorobenzene. So this is the structure of HCB. They consist of 6 chlorine atoms attached to a benzene ring. It is widely used as fungicide for cereal crops after World War II. Is extremely persistent, and toxicity effect is carcinogenic, and therefore it is a possible human carcinogenic. Another example of insecticide is DDT, which is para-dichloro-diphenyl-trichloroethane. Previously, people used a lot of DDT. They said that DDT is very good. This is the structure of DDT. It is basically a substitute of ethane. So here you have two carbon here that comes from ethane. And then you have 3 chlorine atom attached to one of the carbon. And then you have another 2 benzene ring attached to the carbon. And each of the benzene ring have chlorine atom that is attached to the para position of the benzene ring. Okay, so this is DDT. Based on the historical perspective, is widely used to control insect-borne disease such as malaria, yellow fever, that are transmitted by mosquitoes, typhus, plague, and so on. And because of their widely used previously during World War II and slightly after World War II, WHO or the World Health Organization have estimated that about more than 5 million lives have been saved by DDT because of its use as insecticide. But previously it was used to control insect-borne disease, and then slightly after World War II, it was used as insecticide for crop production. Okay, it was used widely in agriculture. Why is widely used is that because it is persistent, it's very stable under degradation, and once spraying, it will last for weeks or years. Okay, So that is why the farmers likes it very much, because they don't have to put pesticides so often. So one spray, it can last for weeks, months to years. It is persistent because it has low vapor pressure, so it tends to degrade or evaporate slowly. And then it has low reactivity to light, so it does not degrade or photodegrade or chemicals and microorganisms. So it's very stable under degradation, and it has low solubility in water. So if you water your crops, or even if with the rain, the chemical is still there because it has low solubility in water. And because of this, they they are, as I said, is resistant to degradation and transportation. However, if they tend to evaporate, they can have a long range of air transport. That's why some of these DDT have been found in the Antarctica, where DDT was never been applied for. It was used in Antarctica, but the concentration of DDT have been detected in Antarctica because of it has long range of air transport. It is persistent in the environment, in the air, and also on the soil. Okay, and those, because of its low evaporation rate, even it was applied for 20, 30 years ago, it still undergoes evaporation. That means it's still there, it still undergoes evaporation, but at a slow rate. It decays slowly. So the concentration of DDT, even in some developed country, it has been banned many years ago, but you will still detect the concentration of DDT. The environmental effect is persisted for several years. It can biomagnify in the food chain. That means that the concentration of DDT can increase in the food chain. Some insects have developed resistance towards DDT. So even if you apply the DDT on the insect, nothing happened to the insect. And it has found that DDT has affected the reproductive abilities of birds. Why is that? Because it interferes with the calcium regulating enzyme. So once the DDT enters the body of birds, they can produce a very thin shell. The eggs they produce, they have a very thin shell which can easily crack. So it made it difficult for the birds to reproduce. And because of this, in 1973, the US EPA, or the United States Environmental Protection Agency, have banned all DDT uses except for those that are essential to public health. Many of developed countries have banned the use of DDT, but because malaria and dengue cases are still high in developing countries, they are still used to control this insect. Okay, so they are still being used in developing countries to control insect-borne disease, such as malaria and also dengue. This figure shows how the DDT can bioaccumulate and then biomagnify in the food chain. For example, we have phytoplankton, the DDT attached on the phytoplankton. So, and then the slightly bigger organism than phytoplankton, for example, zooplankton, they can have an increase in the concentration of DDT. And then the zooplankton are eaten by smaller fish, such as smelt. So, you will see that the DDT tend to accumulate also on the smaller fish. And then smaller fish are eaten by bigger fish, and then these bigger fish are eaten by birds. So all of this, you see that the concentration of the DDT started to increase from 0.025 ppm to 0.123 ppm to 1.04 ppm, and then to 4 ppm, and then suddenly the concentration started to increase to 124 ppm. So this shows that the concentration of DDT started to increase in the food chain. This is what we call biomagnification. Okay, and then because they accumulate in the fatty tissue, you see also the eggs that are produced from the birds also contain high concentration of DDT, because the DDT accumulates in the tissue. Okay, so in the end, it produces a very vulnerable eggs. They have a very thin shell that can easily crack. This scenario has been observed widely, and this diagram shows exactly what happened at the Great Lakes in the United States. Talking about bioaccumulation, okay, this happen if the birds eats the largest fish. So can you think what happened if the human eat the fish? Of course, the DDT also will start to accumulate in human's body. Okay, this shows the concentration of the DDT based on the number of years of the fish. How old is the fish? So you can see that older trouts is the type of fish, the concentration of the DDT are increasing. Okay, because larger fish or older fish, they have larger fatty tissue. So that means that they have higher concentration of DDT. If the DDT enters the human's body, it is slowly eliminated. It is stored in human fat mostly as its metabolic product, which is DDE. The difference between DDT and DDE is at this carbon. The carbon has now is a double bond, and this carbon is attached only to two chlorine atom. This DDE is responsible for the malfunction of the production of calcium in birds or any organism that produce eggs. So they interferes with the production of calcium in eggs. And in addition, DDE is also non-degradable. They are very fat soluble. So it can remain in our body for a very long time. And because of that, DDT is banned in most of developed countries, and I believe in Malaysia also is currently banned. So what can we use to replace DDT? Okay, because DDT is very toxic to human and also the environment. So the less persistent analogs to DDT is that we can switch DDT to chemical of methoxychlor. Why is that? We want the substitute of DDT to have the exact same insecticidal properties as DDT. So we need to find something that is more environmentally friendly. Researchers have found methoxychlor is similar to DDT. Here, what is different is that here, the para position now are replaced with methoxy group. The reason for that is water soluble. It easily biodegradable. It cannot bioaccumulate in a body because it is water soluble. So it's used domestically to control flies and mosquitoes and also in agriculture. So basically here we have methoxy group which can convert to OH bonds, and the hydroxylated product of this methoxy group is a water soluble. So they can be biodegradable. It can easily pass out from urine. It enters into our body. It can be easily excreted rather than accumulated. Other organochlorine insecticide other than DDT is lindane. So this is the structure of 1, 2, 3, 4, 5, 6 hexachlorocyclohexane. So it contains one of 8 isomers of hexachlorocyclohexane. It's also called as gamma isomer because it has insecticidal properties. Same isomer in medical preparations for lice and scabies control. Is also used for treatments of seed and seedling. Other types are chlorinated cyclodienes such as aldrin, daldrin, clodan, chlor, etc. Is used to control various pests such as fire ants, cockroaches, termites, locusts. Undesirable properties are they are also persistent chemical, they bioaccumulate, they cause liver cancer in test animals, and some are teratogenic. And it has been banned in the US. Another type of insecticide is organophosphates. Structurally, all organophosphates molecules can be considered as derivative of phosphoric acid. They consist of a central pentavalent phosphorus atom to which they are connected to an oxygen or sulfur groups. They have two methoxy or ethoxy groups that are bonded to the phosphorus atom. A longer, more complicated characteristic of alkyl groups bonded to this oxygen. Okay. So you can see the basic of structure of the phosphoric acid. Their derivative, they have phosphorus in the middle and they are connected to either sulfur, oxygen, and also ethyl or methoxy groups. They are non-persistent. They are biodegradable with no tendency to undergo bioaccumulation. So they are considered better than the organochlorines. They compose within days or weeks, but they are much more acutely toxic to humans and other mammals than organochlorines. They function as nerve poisons to insects because it inhibits enzymes in the insect's nervous systems. So they are usually used in different ways in the agriculture sector, fumigants or contact poison or systematic poison. It will attack the nervous system of the insects. Some of the undesirable properties of organophosphate is that first it is widely used in homes, lawn and commercial building, in agriculture, and almost everyone is exposed to it. So what undesirable properties? Exposure by inhalation, a swallowing or absorption through the skin can lead to immediate health problem. These are some of the clinical signs that are based on the exposure to organophosphate. It concentrates in fatty tissue. However, our body can quickly excrete this organophosphate through the urine. One last insecticide that I would like to discuss with you is carbamate. So this is the basic structure is the derivative of carbamic acid. Mode of action is through the nervous system disruptor. It's non-persistent, biodegradable, and relatively safe. It decomposes upon reaction with water, forming non-toxic products. We have low dermal toxicity. Some of the example of carbamate is carbaryl, which are widely used as insecticide for domestic, for example, for lawn and garden insecticide and agriculture purpose. Plus, its oral toxicity is moderate. It's only toxic for honeybees. And carbofuran is a plant systemic insecticides that can be taken up by the roots and leaf and is distributed throughout the plants. Next, I will discuss about herbicide. So herbicides are chemicals that destroy plants. Before herbicide was used or organic herbicide was used, inorganic compounds like sodium arsenate were used, but arsenic is of course toxic to humans and there are also persistent chemicals. And organic pesticides now dominate the market. It have high selectivity for certain plants, mean that it focus on the target plant that we want to remove and leave other plants unharmed. And one modern class of herbicide is triazine. This is the formula of triazines. So it have alternating nitrogen and carbon atoms in the six-membered ring. These R1, R2, R3 groups. R1 is usually chlorine atom. Two groups. The useful triazine herbicides contain chlorine and amino or NHR groups bonded to the ring carbon. Best known in this group is atrazine. Okay, so this is the atrazine. You can see the basic group is still here. So this is the R1, the chlorine atom, and then this group is R2, and this group is R3. Okay, what is atrazine? It's mostly used for kill grassy weeds in corn and soybeans field. it was used widely in the US previously. Its more action as herbicide is that it blocks the photosynthesis of the plant. So when you have higher plants such as corn, they are not affected because they rapidly degrade atrazine to non-toxic metabolites. However, the atrazine also have some undesirable properties because it can the concentration can build up in the dry soil. So there is no moisture to degrade, and it can eradicate all plants with high level of atrazine. No plants will grow in the soil that have been sprayed or planted with atrazine. Where this atrazine is sometimes used to clear vegetation to create parking lots. Widespread use can kill sensitive plants in the water system to agriculture field, and EPA have listed atrazine as a possible human carcinogen. Another type of herbicide is phenoxy. So it was introduced as a weed killer after World War II. Herbicide comes from phenoxyacetic acid derivative. The famous one is 2,4-D or 2-dichlorophenoxyacetic acid and 2,4,5-T or 2,4,5-trichlorophenolic acid. So in this case, what the herbicides do that it mimics the natural growth hormones in weeds, leading to overproduction of RNA and plants. So this will cause in their death because their roots won't be able to supply enough nutrition to support the abnormal induce of the growth. So plus this 2,4-D and 2,4,5-T, they are persistent for up to 8 months. 2,4-D is used to control of broadleaf weeds in lawn, golf course, green and agriculture fields. 2,4,5-T, they are widely used for clearing bush on roadsides and power line corridor. However, there have been an increased cancer known as non-Hodgkin lymphoma among farmers in the Midwestern US who apply large quantities of 2,4-Ds.